I welcome you to this online tutorial, the Christmas edition of Formulae Stoichiometry. So we had covered Roman 1. Now we are moving forward with the Roman 2. Roman 2 was on determining volume of the gaseous product. The gaseous product, which is sulfur dioxide. So we go straight to our response. Now for Roman 2, how are we going to move? Still, we are given mass of copper and sulfide. So mass of copper and sulfide, we shall use it to obtain moles of copper and sulfide, then moles of sulfur dioxide, and later on convert moles of sulfur dioxide to volume of sulfur dioxide. However, in this case, we are lucky. We have converted the moles, the mass, we have converted the mass already to moles of copper and sulfide. That has been in item 6 Roman 1. We saw that the moles were 0.2 moles. Therefore, we are going to use these moles to obtain moles of sulfur dioxide. Moles of sulfur dioxide, yes. We apply mole ratio, the concept of mole ratio and the given equation. So we are comparing now copper and sulfide with the sulfur dioxide. And if you revisit that equation back, the given equation, you realize that we have one copper, one sulfide giving one sulfur dioxide. Therefore, the ratio is 1 to 1. So 1 mole produces 1 mole. And as a result, if 1 mole produces 1 mole, then what of the 0.2 moles? The 0.2 moles will produce 1 over 1 times 0.2. And this gives 0.2 moles of sulfur dioxide. Therefore, since we have moles of copper and sulfide, we convert these moles to volume of sulfur dioxide. 1 mole, how do we convert moles to volume? We convert moles to volume using the concept of molar gas. From the mind map and also from the information given in the bracket for item 6 Roman 2, from that information says that 1 mole of a gas occupies 22.4 decimeters cubed. In particular, 1 mole is equal to 22.4 decimeters cubed. So if 1 mole is equal to this, then what of the 0.2 moles? The 0.2 moles will equal to 22.4 times 0.2, and computing this will obtain 4.48 decimeters cubed of sulfur dioxide. So this is approach 1 of item 6 Roman 2. However, Roman 2 still has a technical approach. So for the technical approach, we interpret the equation directly. How? We say that from the given equation, 1 mole of copper 1 sulfide produces 1 mole of sulfur dioxide. So what are we given? For copper and sulfide, we have mass. So 1 mole, in terms of mass, 1 mole is equivalent to molar mass. Since for copper and sulfide, we are given mass. So here we are going to substitute molar mass of copper and sulfide. However, for sulfur dioxide, maybe let me first substitute for copper and sulfide. So we substitute 64 times 2 plus 32. This is the RFM of copper and sulfide. Grams of copper and sulfide produce 1 mole of sulfur dioxide. Now for sulfur dioxide, we are interested in volume. So here you do not substitute RFM of sulfur dioxide. You do not substitute molar mass of sulfur dioxide. Why? We want volume. And in terms of volume, 1 mole, in terms of volume, 1 mole is 22.4 decimeters cubed. Then computing this will obtain 160 grams of copper and sulfide, produce 22.4 decimeters cubed of sulfur dioxide. Then what of 1 gram? If 160 grams of copper and sulfide produce 22.4 decimeters cubed of sulfur dioxide, 1 gram of copper and sulfide, 1 gram of copper and sulfide will produce 22.4 over 160 decimeters cubed of sulfur dioxide. Then what of the 32 grams in question? The 32 grams of copper and sulfide produced 22.4 over 160 times 32. And computing this, we obtain a volume of sulfur dioxide as 4.48 decimeters cubed. So as of now, allow me first stop here.